everyone. Welcome to the 427th episode of the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And we have so much to talk about this week. We're going to be kicking it off with Kevin's take on device script, because I feel like anybody who's listening to this show might enjoy playing around with Arduinos, and this is a good thing for that. We're also going to be talking about Google Home's new smart automation script, new products from Vivint, and another section on privacy and all the ways that the IoT is really eroding that, and how the U.S. government is using it kind of surreptitiously and perhaps unethically. There's also a few new devices out there that we're going to talk about, one for your health and one for seeing who's at your garage door. And we'll end with a little bit on ARM. We're also going to hear from our guest, Thierry Klein, who is the president of Nokia Bell Labs Solution Research. And he's going to talk to us about, building an LTE network on the moon.
Woohoo!
And how this might apply to the IoT. We're also going to hear from our sponsor, Blink. But first, a message from another one of our sponsors. This week's sponsor is Particle. Are you looking to fast-track your IoT project? Join Particle at their user conference on June 21st. The event is Spectra, and you can use it to learn why Particle is the fastest way to get started on IoT. As the leading IoT platform provider, Particle is committed to making IoT accessible to everyone. Their newest Wi-Fi module makes it easier than ever to get started. Join them at Spectra for first ever access to the Photon 2 and to hear all about exciting enhancements they've made to the platform. Whether you're an experienced developer or just starting out, Spectra on June 21st is where you'll find the latest information for Particle customers and users. Visit spectra.particle.io to register. Woohoo, Kevin. All right, I'm going to give you the mic and have you lead off the show with your review of device script. First off, what is it?
Device script. We talked about it on a show maybe 1 or 2 episodes ago, but it is Microsoft's new, I'll say, coding language for the IoT, and it applies specifically to microcontrollers. So it's not going to be for like big honking devices. It's more for sensors and lights and things like that. So why do we need another coding language, you might be asking?
Always.
It's on everybody's mind first thing in the day, right? Well, no, let's go back in time. Not too many months ago, you were doing IoT type coding on an Arduino.
Yeah, I took a class. It was super fun. I hooked up an Arduino, I wired it together. Then I used its IDE and some other random program to talk to the IDE, to make lights blink, to make other things happen. Little servo go.
Yeah, well, and that's a lot of DIY people and tinkerers build products like that, their own one-off things, or maybe device makers, Arduinos and other types of microcontroller boards to prototype a new IoT device. But the Arduino language is like, it's kind of out by itself. It's a one-off thing, even though it's built like on C++, and you can use other languages within it, but it's kind of just old. I know they're working on it. I'm not trying to complain about it. I'm just trying to set the stage that something more modern might be helpful. And since JavaScript is the language of the web, Microsoft decided we're going to make TypeScript, which is like a super set of JavaScript, and DeviceScript is their TypeScript flavor of IoT coding, I guess. It's probably the best way to say it.
Yeah, so basically instead of using Arduino's programming or some other option for programming your Arduino, this is a different option that is a little easier. And even I, when looking at that code, I was like, oh, I can tell what this does. That's kind of fun.
It's more of a commonly used. I mean, JavaScript, TypeScript, kind of the same thing. Let's keep it simple and say they are the same thing. It's the language of the web, right? It's what's running in your browser. It's what's running on servers. It's what's transferring data through something called JSON. We've talked about that before. So it makes sense to have something more common and easy to read. And that's exactly what DeviceScript does. And it's very simple to install because it's just an extension in Microsoft's own Visual Studio Code development environment, which many people use, not everybody. There are other good ones out there. What I liked about it, aside from the very quick setup, I could run one command and have the extension build an empty project for me. And literally, it grabbed everything that I needed. It put all the folders in the right place and it's ready to go. That was it. It just took literally 5 seconds to do that. And then it's just a matter of, creating something. So you really could use a Raspberry Pi Pico board or an ESP32 board for this and push your code to those devices. I don't have any of those, so not to worry. The device script extension has a simulator, and you can simulate LEDs, light bulbs, thermostats, humidity sensors, motion sensors, on and on and on and on. So that's what I did. And I just kind of went through one of their examples using the LED blink. It's kind of like the hello world of IoT programs, the first thing everybody does, isn't it?
Yes. You're like, make this LED blink. Yes. And then if you want to get fancy, then you wire it a little different and you do like a sequence of LEDs that will blink. And
yeah, you spell things out and make numbers. You can do all kinds of stuff. But anyway, I simulated that and it was literally so easy to do. Now, granted, I am learning JavaScript, so I'm familiar with the syntax of TypeScript and device script essentially. But Stacey, you said it best. Even I could understand it. I mean, there's not a lot of code to make the light blink, and you can see it's understandable.
And it makes physical programming, like programming of physical devices, more accessible to people who are used to programming on the web, which is, there's both a back and forth here. Like, I'm good at the web, and now with the Internet of Things, I need to get good at physical things, and vice versa. All the old guys who know C++, and they're like the double E's running around programming physical things, they're actually like, oh, I need to get better at the web because the IoT is pulling all of my stuff up to the web. So it's kind of like this. I mean, device script doesn't help with that, but
yeah, but no. I mean, conceptually, that makes total sense. There's even some additional tooling in here where, for anybody who's familiar with Visual Studio Code, any program you're writing, you can like watch certain memory registers or variables that you've stored to see what the data is as the program is running. I was able to do that with the light. Is it on? Is it off? I could tell that. Obviously, I could see it in the simulator with the little thing blinking, but you may not need something or want something as simple as that. You might need some complex data to see what's being transferred or who knows what, but you have that tool as well. So it's a fairly complete package, even though it's early days yet. So overall, I liked it. And I noticed that the Blues wireless card that I have in that Blues wireless LoRa dev kit, the Sparrow dev kit that I reviewed back in September, that's actually supported too. So I may tinker some more with this and see how it applies to a real device. I would have done that, except I didn't notice that until I was 99% of the way done through my basic look. So, but I like it. I'm impressed by what Microsoft has offered here.
We'll keep you around, Kevin. You can try that later.
Oh, thanks.
Okay. Now, speaking of scripts, Google Home Script Editor is now live. And they had talked about this a while back. And this is just a more programmatic way to program and build automations for your Google Home.
Looks groovy.
It looks groovy. I was actually going to bring that up. So this is in public preview. This way, it's already available. So it should be available. You can find it at Google's home.google.com web interface. That's also where you find your desk camera feeds if you want to look up on the web. So this is a way to do this. If you're like sick of that GUI interface or you want to do something a little bit more complicated, you can go in and start playing with this. This is for the people who like want to start automations 10 minutes after sunset and in that kind of thing. It's also a really great place to go to troubleshoot. So SmartThings had this way back in the day with Groovy, and it was super powerful. I actually used it a couple times just to troubleshoot things that were happening and see, like, because my smart home setup is so stupidly complicated, I would go in and be like, why is this device turning on? What is controlling it? And I could usually find that out there. SmartThings killed that. But Google's like, yeah, we'll do it. And you do need to know how to code. I mean, you don't actually. You can
parse it out and figure it out. I think.
Yeah, you can. I mean, I'm looking at it. I can figure out things. Usually, I'm like, oh. And if you, the fun part is, if you can't figure out what it does, you can always put something in it, and if it works, you'll physically see what's happening.
Yeah, for anybody who is a developer or has tinkered with development, it is an object-oriented approach, just like DeviceScript, in fact. So you can say, I want to run the fan speed method or set the fan speed property on this device that's in this state. It's almost like a pick and choose from a menu to decide what you want to do, which is nice.
Yeah. So that's that. It also brings Google up to par with some of the more fancy automations because I use Google Home. I don't use it for my automations very much because it has been historically so limited. Like you can only do one thing and you can't do bunches of things. And it's a real blunt tool. This gives it a little bit more fine grained resolution.
Not only that, but apparently, and I did not know this, you cannot use a Matter device to kick off a shortcut currently in Google Home. However, you can use Matter sensors to be a starter for an automation in the script editor. So you actually gain some.
Oh, that gives you the ability to use your sensor because Google hadn't had sensors as triggers for a long time.
Exactly.
It's real stupid that way.
Exactly.
Okay. Well, good for Goog. Okay. Let's talk about Vivint. I know you've got to be one of the 1.9 million Vivint subscribers for this really to appeal to you or care about this right now, but I'm talking about it because I really like their physical hardware and I like what they've been doing historically with AI. It's been very advanced. So they've actually kind of been on par with someone like an Amazon or a Google in terms of releasing hardware that's a little bit smarter and more adaptive. And sometimes they've even been ahead of the game. So I always kind of try to keep an eye on Vivint just because I like what they do. They've gotten into smart lighting. So this week they released a kit, and this again is only for people who are either Vivint subscribers already, or if you want to become a Vivint subscriber. It's a lighting kit and it's $299 plus a $5 a month subscription fee. So keep that in mind. The kit will include a gateway, 8 bulbs, and 2 of their switches. What they've done here is they've just created an entire package around Zigbee light bulbs and switch covers. So y'all are all aware that when you install a smart light bulb, if you turn off that bulb at the switch, it just dies. It's now
You've lost control over it.
Incommunicado. Yeah. So they've solved this problem. I solved that problem by buying Lutron switches, but people may not want to wire their house. I get that. So they solve that problem by making these fairly attractive looking covers that you just screw onto your existing switch plate. You leave the light on underneath the cover. And then the cover itself has a battery and a Zigbee radio inside. So you turn the light on or off with that false cover. Just like with like the Lutron Picos and stuff, you can use these covers anywhere. So now you have like the equivalent of a Pico remote that you can program to do things and place anywhere in your home, even if there wasn't historically a light switch there. So I like this. I really do. The subscription fee, I don't love. Mm-hmm. And right now, the features that they call it mock-occupancy. I can't say that word, but the idea is
mock-occupancy.
Yeah, mock occupancy, which, Philips Hue has had tons of lights have incorporated this feature, but it's basically like, hey, when your light system or your smart home automation system determines you're away from the house, it says, oh, well, let me just run the lights in the house that I have access to like someone's home. That's all it is. But it's a nice security feature. Mm-hmm. They don't have circadian rhythm yet, but they will. So circadian lighting is the other thing that I think most people look for when they're looking for quote unquote smart bulbs, not just connected bulbs, but those that are actually smart. So that's this product. I think it's really interesting. If you're already paying Vivint a subscription fee, I guess $5 extra a month for the lighting might make sense.
I mean, if you're going to do your whole house, it might make sense because the $299 gets you a really good starter pack and they say you can add on to it.
Yeah, you can add up to 150 bulbs and switches, which is a lot.
So you spread that out over the $5 a month because the subscription fee for this does not go up. It's a flat $5 fee. I mean, if you're going to redo all of your home lighting, $5 is actually not too bad each month.
Yeah. But
yeah.
But
I was looking on the bright side.
I was like, I've now owned my Philips Hue bulbs. Like I still have, I don't have the original gateway, obviously, because that has been decommissioned. But the bulbs themselves, I still have a few of my original ones. And those I bought 10 years ago now.
Yeah. So basically you've paid like $5 a year for each bulb.
Yeah. I mean, they were expensive. They were like $50 a bulb, but that's better than like $600 for lights.
Yeah. For a lighting service.
Yeah. Yeah. Anyway, so take what you will away from that. Let's talk about, privacy.
Here we go.
Wired is just on a roll. This month, they did a bunch of really good stories about things that should scare the bejesus out of you. First, back in March, FBI Director Christopher Wray confirmed for everybody in Congress that the FBI does purchase U.S. phone geolocation data. And everyone was like, holy moly cow. And this is important because this geolocation data, obviously, it can be used to track people who may have gone to abortion providers. It can also track like people who may have just been in the wrong place in the wrong time. So they would buy that from data brokers. So this was part of a classified report that the FBI had. And Congress and public rights groups were like, you need to release that report. And so now it's been declassified. And this is from the Office of the Director of National Intelligence is this report. And so the report itself, we'll link to it, but it basically, they don't have to have a warrant to get this information because they can just buy it from an independent data broker. So the issue is you can use it. This is credit card data. This is your location data. This is a lot. And what might be even more galling is you're actually funding this with your taxpayer dollars. So they're like circumventing your rights with your money. I mean, it's a little over the top, but it is true. So basically, there's not a lot of avenues for a fix here. The FTC actually tried to sue and come after one of these data brokers, and a judge was like, you haven't actually proven enough harm yet to find this and stop this. So the FTC has to come back and try to figure this out. So what we have is the government buying data, phone data, credit card data, data that can track where you are. Because remember, your phone data is personally identifiable in the sense that most people go to their homes each day. They have a fairly regular schedule. And if you do that, it's pretty easy to figure out who that person is. And it's just a lot.
Plus, when you buy a phone through a carrier, you have to show ID. I mean, yes, you can buy burner phones and whatnot.
The phone providers know who you are, but the phone providers don't give that information up without a warrant.
Without a warrant, that's correct. That we know of.
What's the issue here is you could, without a warrant, come and get this information, just buy it from data brokers.
I'm getting to the point where, and Stacey knows this, I've been moving slowly away from, we'll just say, big tech usage and moving more towards open source systems and so on. And I have not completely moved because it's very hard. Like it's a huge obstacle now to try and get yourself out of, say, the Gmail world or, whatever operating system you use or whatever phone you use. How do you do that, right? It's very challenging. But I'm trying to give less data to anyone at this point.
Yeah, that might sell it for commercial or civil.
Yeah.
Municipal governments. So at least we're out there running around and being tracked only from our phones, and we could leave our devices at home.
Well, if you're a good person, that is. If you follow the law, yes.
I was going to say a good person, or if you just don't get caught breaking the law. I feel like we should just say, if you don't get caught breaking the law. Wired also had a really dystopian, I'm just going to say it's a dystopian story about surveillance within jails using RF signals and sensors in the walls and wearables on the inmates. This is from a company called Talatrix. They talk about its use in the Fulton County Jail, which is a very bad jail. Like, federal government is like, whoa, Georgia, what are you doing there? So what this is, it doesn't just track like where the inmates are in the jail. It also tracks their heart rate. And
yeah.
I don't love this. I don't love the fact that, a jail is a surveilled place, but what this is fewer people want to become prison guards. So there's fewer corrections officers. And so to make up for that, they're turning to technology. And I don't like this for many reasons. One is the privacy angle. Two is anytime you see technology sold into the prison system, it is overpriced and underperformant and also doesn't typically work all that well. But then it becomes incumbent on the inmates who don't have a lot of agency in this area to prove that it's not working well. So they may get in trouble for like something that is not their fault, but it is a function of poorly functioning tech. So these trackers track people's heart rate. They're going to look at oxygen tracking. The people who are deploying this say that this is for health reasons, but I can't believe that. And it's not like corrections officers are known for their like empathy and ability not to like spy on people from that perspective or use that data against someone who's already under their thumb.
Yeah, I mean, it's just, I'm going to sound terrible saying this, but I'm going to say it. It sounds like a great test bed for this type of technology because there's not a lot of empathy there. People who work in the prisons or even people, the general population may feel that the prisoners just don't have the same rights as everybody else. And who cares if we track their heart rate and their oxygen levels? And I don't agree with that. But again, this is a terribly good test bed for this.
Yeah.
You're in a position where you can't not comply with it if they bring it to your prison, right?
Yeah, you don't have an option to say no.
No.
Maybe if there's nickel in the wristbands and you have a nickel allergy, but even that would be hard to convince people because it's not like people who are deploying this care. Anyway, this is depressing. And I can also see a future where we start seeing like AI deployed on top of this to like, you could get pre-crime. You could put people in solitary because their heart rate gets too high when they get near somebody. You could use that as a threat.
Yeah.
Yeah, it's not great. Okay.
How about a device that does good?
Is it good?
I think for you, yes.
All right. Tell me about it.
So this is from a company called Stat Health. It has a new in-ear wearable called, appropriately, Stat. And it measures blood flow to the head. Basically, it's got sensors in it to track your blood pressure and your blood flow, and it can accurately predict fainting minutes before it happens. And again, I think this is a good thing. Oh, Stacey just fainted.
I'm done. I do faint a lot. And there's also a growing epidemic. I don't know. There's also a lot of people who have POTS, which is postural orthostatic tachycardia syndrome. And that's actually something I have. And basically what happens is when you go from sitting or lying down to standing pretty rapidly, your heart rate goes whoop, right up and you don't get enough blood flow to the head and you just fall right back down. So it's very simplistic, but what happens is you faint a lot. And I've already broken my nose once because I fainted and smushed my nose. Now I'm a little bit better about getting to the ground first, but having some sort of wearable that gives me a little bit more notice would be great. My mom also has this issue and faints like walking down the stairs, which is scary beyond belief. So again, having that warning is great.
You can stop, drop, and roll.
Well, you just stop and drop, really. But yes.
Well, you never know. Rolling might help the blood flow. I don't know.
Sure. But it costs a lot. How much does it cost, Kevin?
It's got a subscription fee. Are you ready? It is $50. But that's not for a year. That's per month. Holy cow.
Yeah.
I mean, they're just rolling this device out, and that's the target subscription fee. So it can change. They're now taking pre-order reservations for $1, but that's a lot, or potentially a lot.
Well, is it a lot if you don't pay for the device? What if it's $50, you get the device, and then...
Yeah. See, device is it's a sunk cost, right? So I'd be fine with a much smaller monthly fee and say it's a $300 sunk cost for the device. And let's make it $10 a month and $100 for the year to give you a break. That just seems more reasonable to me because $50 a month, that's $600 a year.
Well, this is a medical device.
Agreed. But
yeah, it's a lot.
It's a lot.
I mean, we pay $30 a month for a Lively button for my mother-in-law, less for fainting, but just in case she falls.
Right.
This could, because it has an accelerometer, probably be used also if someone falls. So you could, for someone like me, I mean, it doesn't call people. So I guess it doesn't function that way, actually. I was like, oh, but it could tell something, I guess, that I've fallen. I guess it has to talk to something to tell them you're about to faint.
Listen, for people who this would benefit, I do love the sound of the product and what the benefit that it brings. I'm just, that's a lot of money. So let's see what happens.
It is a lot of money, but I mean, when I fell and broke my nose, it costs quite a bit to go to the emergency room, get a scan for my brain, and then
But that's your sunk cost in your nose. That's not enough fee. No, I'm kidding. Yes.
But if I keep doing it, eventually those concussions will add up.
Well, they should give you a discount the second and third time you break your nose from fainting.
Really should. All right, so that's an interesting device, and I'm really excited about it, especially if this technology could be built into something like an existing hearing aid. Whoa, paging Starkey. Okay, let's talk about a new device for your smart home if you're still building out your smart home. MyQ has a new smart garage video keypad. Basically, it's a video doorbell, except it's on your garage and it's keypad for opening your garage. For those of y'all who have a keypad on your garage, you probably have children and you probably use your garage as a main way of getting in and out of your house. I rented a home actually that had this function, and it was our main door in and out of the house, like walking the dog or going places. We never went out the front door. This could be a great product for those people, because like when your kids come home from school, you could be like, they'll enter the keypad to get in the garage and you can see their little faces and be like, hey. Or maybe if you let your kids free range over the summer, like my parents did to me, you know, when they're grabbing their bikes out of the garage and closing it back up, you could be like, hey, remember to come home for lunch or whatever.
Yeah, no, and it's not like a ridiculous monthly fee if you want the video plan that they have to like review stuff. It's $3.99 a month. I mean, it's not a big deal. They already offer that plan. It would be part of that plan. So if you're already paying, you'd be covered if you want that.
It is a neat thing. It ties in with all of MyQ's stuff. I don't currently live in a place where our garage is our main door, so it's not as useful for me. But if you do, I can see this being like pretty neat.
By the way, that plan for this particular video keypad would include person detection and rich notifications as well. So that's kind of handy.
Yeah. You can also remotely open the garage door from your phone if you want. I mean, like, this isn't for your kids, but like, I don't know, if you've got a package coming, you'd be like, leave it in the garage and open it up. More likely, you're going to want to close it. Most people leave their garage door open and think, oh, crikey, and then want to close it. But, you know, I'm in an open mood today. The glass is half full. Final little story here. ARM, our favorite IoT chip maker, because they make the M class of microcontrollers. They have the A class of devices that are in your phones that are used as controllers for IoT devices all the time. You know, we've talked about them after they didn't get bought by NVIDIA. They are trying to go public. They're asking Intel to be an anchor investor in their IPO. They're expecting to raise $10 million in this IPO, which is a lot.
10 billion.
Billion with a B.
Yes.
But SoftBank has to make money because they spent a lot buying ARM. So that was back in, I think it was 2015 that they bought ARM for $32 billion.
It's about right. Yep.
A lot of money. So they're asking Intel to pony up as like when a company issues public stock, when they do an IPO, what they're doing is they're selling shares in the company to investors. And that could be an investor like me, but most often what happens is big banks and other companies will pledge to take on like X amount of the offering. So in this case, ARM is hoping Intel might take 100 million or 200 million worth of shares. And what this does is it helps set pricing and stuff like that. So they'll buy it at whatever price gets set, and then those shares are traded on the public market, and eventually they could sell those if ARM's price goes higher and make money. That's the idea. So that, I mean, this is fine. I just am kind of like, man, anytime Intel touches ARM, the ARM part of it dies. I've seen it before. They had that Xscale acquisition. They've tried some other deals with ARM.
I think it's part of their strategy.
It is. Intel's like, oh no, I don't think they're trying to kill ARM. They missed that boat. So anyway, that is all the news so far this week. But now it is time for the Internet of Things podcast hotline, the section of the show where we hear from you, our listeners. The IoT Podcast Hotline is sponsored by Kudelski. Are you building an IoT device? Evolving threats and compliance with regulation are complex. But Kudelski IoT Security Labs can help with threat assessments, device security reviews, and much more. Learn more at kudelski-iot.com. Okay, I have to tell y'all, this month we are giving away a Keurig Smart Brewer. This is very exciting. It is a Keurig coffee pot thing with also the attached milk frother thing. And it's got a lot of things there. It has an app and it will make your coffee like you want it to. Now, I have to tell you, I played with this thing. I can't tell the app to send my coffee recipe to the Keurig. I still have to press the buttons, but it tells me which buttons to press in the order, which is nice. And I can even hook it up to my Madam A device, and then I can say, Madam A, brew my coffee, and it will. Or I can set it up as part of my morning routine, and that is also neat. So this is what you will win. It's very exciting. But you have to call us at 512-623-7424 and ask us a question. We would like your smart home questions or your industrial IoT questions or your questions about, Matter, whatever. Give us a call, 512-623-7424, and you'll be entered to win this particular smart coffee maker. Yay! Okay, this week's question, I'm just going to tell you, it's a doozy. Let's hear it.
Hello, Stacey and Kevin. My name is Greg, and I am a HomeKit user, but I am thinking about bringing the new Habitat into my home because my understanding is it can be integrated with HomeKit. And I've got some Z-Wave wants that I'd like to bring into my home. Question I have for you is, I have a gate on the back of my property, which is why I'm interested, part of the reason I'm interested in Z-Wave. And it's got a deadbolt in it. And I would like to find a Z-Wave lock, but one that doesn't have an external keypad. Basically something that just looks like a lock. I like the level bolt for this reason, but it's only Bluetooth and I can't reach that far back. So I'm trying to find a way to use Z-Wave because my understanding is it's got a much longer resistance to secure that gate that has a deadbolt on it in a way that does not advertise that it is a smart lock to people that might be walking by the other side of that gate. Hope you might be able to help me find some answers. Love your show. Thanks.
Okay, so here's why it's a doozy. There's two challenges. One, getting a smart lock that's going to be exposed to the elements all the time.
Both inside and outside.
Inside and outside, right. The outside of our locks, obviously, but the inside of this one will be inside the gate, which is really still outside. So that's a challenge. And secondly, is finding it's the range and accessibility of what can connect to something farther away. And there just aren't any specific gate locks that we could find that will meet either of these needs.
The smart gate locks that exist are powered, so they need power going to the lock. And they're designed for, again, powered gates that open and close.
More commercial type. Yeah.
Yeah. Or if you have like a long driveway and a fence, like a security or access control kind of perspective. And then it's a proprietary access control system, which I don't think you want here, Greg. And you also didn't want it to you didn't want it to be a keypad or have any functionality that looks like a connected lock. You just wanted it to look normal. So we found some workarounds that are terrible. So we'll tell you about some general workaround ideas. If you wanted to do something with a normal looking lock, the level lock is an option, but you do need that Bluetooth extender, which I think is not going to work for you. And you would need to put in a 4x4, like that your gate latches into, and you'd have to mimic a hardier door for any of that to
the
work.
Thickness of door, in a sense, because that's where the lock is going to be so hidden, so to speak. And I actually thought that the level lock would do the trick because I'm like, hey, isn't that an Amazon Sidewalk device now? And it is, but it doesn't use the longer range 900 megahertz frequency. It still is a sidewalk device that relies on Bluetooth, which really is kind of pointless in this case. I was disappointed because it's like, oh, it's sidewalk, it'll work. And Stacy's like, nope, because they use Bluetooth over sidewalk for that.
Yeah. So that's not a great option for you. Kwikset makes a lock. It's a fingerprint lock that looks like a lock only on the outside, but it does need your fingerprint. So again, in that one, they do have a Z-Wave version of it. So you could try that. But again, you're going to have to retrofit your gate, which I'm imagining you don't want to do.
We don't know the thickness of his gate, so it's very possible that it's a solid thing like a door. I don't know.
Well, that's true. I mean, and you'd have to mortise out the little hole for the
Deadbolt
latch to go into and the deadbolt to go into and all that. I mean, it's not an impossible project, but it is a project. And then again, you'd also have to build some sort of cover to cover the electronics that are still on the inside of your backyard, but exposed to the weather.
That may sound like a kooky idea, but that is exactly what somebody on Etsy sells. They sell, and it's not for that particular lock, they sell an outdoor gate smart lock adapter for the August smart lock. And so if you bought an August smart lock, they will literally they will fabricate a gate lock, sliding gate lock thing, and they have an attachment that makes the August lock turn inside and pull or retract the gate lock lever.
It's a Rube Goldberg machine.
It is. And there's a 3D printed cover to protect the August from the elements. So literally it would work. And it's $30, but you have to have an August lock to do this. And I don't know if, it's handmade. I mean, if you want support or anything, I don't know that you're going to get that.
Yeah. So, I mean, your best bet, I understand that you don't want to have a keyed lock, but we did find some lovely, very sturdy keyed locks, but you do have to have a key. So, and it's not smart. And that may not be what you're after. If anybody listening has solved this problem, by gosh, give us a ring. We'll enter you to win as well.
I'm betting if they have, it is a Rube Goldberg style approach, but that's okay.
Yeah. I mean, this is a problem I cannot solve for you, Greg, as much as I would like to. I can only offer you.
She can make a light blink on an Arduino board. I can tell you that.
But I can't give you distance, weatherproofing, and a good non-keypad lock for your gate. All right. But if you would like us to rain on your parade or or maybe answer your question, give us a call at 512-623-7424. That concludes this segment of the show, but please stay tuned for our guest, Thierry Klein, who is president of Nokia Bell Labs Solutions Research. And he's going to be talking about building an LTE network on the moon and what we can learn from that for the IoT. Honestly, we talk a lot about the difficulties of building a network on the moon, but it's really fun. If you're into space, if you're into networks, you're gonna love it. But first, a message from our sponsor. This week's sponsor is Blink. Hey everyone, we're taking a quick break from the Internet of Things podcast for a message from our sponsor. Today's guest is Pavlo Beborodin, who is the founder and CEO of Blink. Blink is a low-code IoT software platform used by over 500,000 developers and businesses globally. So, Pavlo, thank you for joining us today. Can you tell us a little bit more about Blink?
Absolutely. Blink is a low-code IoT software platform for manufacturers of electronics goods. We provide companies with a self-serve solution for their IoT software needs, everything from a hosted private cloud and firmware libraries to white-label mobile apps and a business management dashboard. Our typical customer is a company that is great at building hardware products, but is not an expert in software and doesn't want to be one. Basically, we eliminate the need for an expensive engineering team and dealing with multiple service providers, which allows our clients to focus on their core objective, building and selling great connected products.
So maybe you could share some examples of how businesses have used all of these capabilities?
I have two favorite ones, actually. The first one is a company that builds tobacco and vape smoke detection devices for schools. When they signed up the first client in December, they only had 2 weeks while school was empty for Christmas holidays to deploy a fully working commercial solution. Their prototype was already working with Blink, and they focused on the installation itself. And in parallel, their business server was launched, mobile apps were published to the app stores, and in January, just 2 weeks later, first vaping alerts were already coming to the school stuff.
And what is your other favorite use case?
The other one is a US company that builds slick and cute AC units. When they found Blink, they had all the product and manufacturing sorted out. They even knew how the app should look like, but didn't have anything built on the software side. What really amazed me is that they had a great business team, but no engineering in-house at all. And about 4 months later, their ACs were ready to be shipped, the whole cloud infrastructure was ready and waiting for these devices online. Apps were built, with no coding by the way, and published to the app stores. Alexa and Google Home skills were ready. And now this product is a huge success.
You mentioned that they built apps without any coding. Can you tell me a little bit more about that?
Sure. Blink app is a native iOS and Android app that works in two modes. One is a constructor mode, and the second is a customer-facing mode. In constructor mode, you can choose from dozens of customizable UI elements like buttons, sliders, charts, maps, gauges, you name it, and then drag and drop them to the canvas to create a custom UI for your connected product. We support multiple pages, various interactions, and a ton of other features designed specifically for IoT use cases. Once the UI is ready and it works with the device, you can share it with the client, and they will be able to activate their device by connecting to the Wi-Fi network, start using it, get important alerts, share access to the device with other users, create automation scenarios, and much, much more. All of that with no coding involved. But the best part is that these apps can be branded and published to the app stores under your company name.
Excellent. So where should our listeners go to learn more about Blink?
Go to blink.io, that's blynk.io. Try the platform with a free account or get in touch through our contact form. We'd love to hear from you.
And that is Blink, blynk.io. Hey everyone, welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and today's guest is Thierry Klein, who is the president of Bell Labs at Nokia. Hi Thierry, how are you doing today?
Great. Hi, Stacey.
I am really excited to have you on the show because we are going to be talking about building an LTE network on the moon, which I believe y'all are doing, yes?
Yeah, absolutely. One of the most exciting projects that I've been involved in my career.
Man, I have so many questions. It was hard to narrow this down. But first, let's talk about what you're actually building on the moon and what this network is for.
Yeah, absolutely. We have a project that's in collaboration with NASA and two startups in the space industry to really deploy the first cellular network on the lunar surface. And this is really a demonstration mission that's supported by NASA's Tipping Point program. And the goal of this mission is really to demonstrate that the communication technologies, whether it's 4G, 5G that we're using every day in our terrestrial networks that you and I use every day, that we can take those same technologies and we can adapt them for space applications. And we can take the technologies, harden the equipment, adjust the equipment, adapt it for the particular situations on the lunar surface. So that's really the goal of this mission. We'll provide what we call lunar surface communication. The network itself will be mounted on a lunar lander that's provided by a company called Intuitive Machines out of Houston. And the user equipment, or what would be the equivalent of your phone, is mounted on Lunar Rover that's provided by a company called Lunar Outpost out of Boulder, Colorado. And we'll establish a communication link between the rover and the lunar lander. So as the rover is driving around on the lunar surface, we'll be able to connect the rover to the lander and be able to remotely control the rover, but also get telemetry, video, images that are collected by the rover as it drives on the lunar surface and send that back to the lunar lander and then ultimately back to Earth and mission control.
And to be clear, this is an LTE network that is only going to be operating on the moon between the lander and the rover. We're not using LTE to communicate from the moon back to Earth.
No, that's correct, Stacey. It's just really for the lunar surface communication, and then it's a satellite link back. And actually, there's a second robotic payload. Besides the rover, there's also a hopper that Intuitive Machines is deploying on the lunar surface, and that would also be connected on the same network. So we connect two robotic payloads, a rover that's driving and the hopper that's hopping on the lunar surface, and they both connect to the same network on the lander.
Okay. I'm used to thinking about gigabit speeds and miles long coverage and a network that lasts for a while, but this is a short-term network. And what kind of speeds, how big of a network are we talking about here? Give us some of the fun specs.
Yeah, there's lots of different specs, but let's talk about maybe more the traditional communication specs. The network actually provides more capabilities than we would really need for this demonstration mission. We're looking at two primary objectives for the different payloads. The rover will drive around the lander in sort of a short range drive, think 200, 300 meter circle around the lander. And it will communicate back to the lander. And then it will take a long range drive where we'll drive about 2.5 kilometers away from the lander. And we provide communication capabilities during that. The network itself can extend much longer from a coverage perspective, but that's really driven by the operations of the mission. And throughout this the mission, we have several megabits per second of video and telemetry data that we send. And the network has much higher capacity, but since we only have one terminal that we're connecting, it's limited to that several megabits per second, which ultimately the throughput that you would experience on Earth is limited by the moon to Earth backhaul link. So the capacity of the network on the surface is much more than what we can support on the link back to Earth. And that's ultimately the bottleneck of the network. And then this small hopper will have the same performance in terms of throughput of video and images we send back, but will be about a kilometer away from the lander, and it will be hopping on the lunar surface. Will actually hop into a crater where it's then looking for water and ice on the lunar surface. So that's a quite exciting mission as well. This mission is called Intuitive Machines 2, the IM2 mission. And one of the objectives is to explore the South Pole of the moon and look for, evidence of water and ice on the South Pole.
But not penguins.
Not
I'm
penguins,
kidding.
no.
Why are we building out these networks in space?
Stacey, I think this is a really important question. When we look at the vision for going back to the moon, the vision for going to Mars eventually, and we think about those missions, it's absolutely critical that we have communication needs. It's absolutely clear that those missions will not succeed without advanced communication capabilities, whether it's voice communication between astronauts and mission control, whether it's video, data, telemetry applications. These missions will have long durations, will have lunar habitats, will have scientific payloads, will have robotic assets. And all of these assets on the lunar surface will need to be connected. We want to control them remotely, maybe. We want to communicate with them. We want to collect information and data. And so the future lunar economy looks very similar to an industrial enterprise environment. If you think about a mine in Australia and you compare that what a lunar deployment would look like, especially if we think about mining on the lunar surface, it's actually very, very similar in terms of the communication requirements and the communication needs that we have. So taking advantage of the technology that we have to support these future missions and a future lunar economy is really critical to, I think, all the space agencies globally, as well as commercial missions that will go to lunar surface, Martian surface, and where we see a tremendous acceleration over the next 10 years. And communications will be an absolute critical component of the success of those missions.
Now, you touched on this, I think, a little bit, but I really want people to understand, this is a big deal because historically in space, even with the Mars rover missions, we've had communications networks, but they were not cellular based. So can you explain what we're used to in space?
Yeah, I think it is a big deal because really for the first time, we're taking the technology that we're used to every day and quite frankly, all the investments that the telecommunications industry has made into these advanced communication technologies that we use every day and in our daily lives, in our personal, professional communication, in service provider networks, in enterprise networks, and really take those same technologies and saying, why are we reinventing the wheel? Why are we creating new technologies instead of leveraging what we already have? So that's really the big deal, to show that we don't have to start from scratch. We don't have to develop technologies that are specifically for space missions, but we can leverage all the investments and the ecosystem and the technology that's been developed. What we've historically have used is actually still a lot of voice only, and very limited data. And a lot of it is UHF, VHF technologies. There's some Wi-Fi being used in space, but by and large, it's proprietary, purpose-built technologies for the space missions.
When you talk about the bottleneck being satellite has come a long way. But when we're talking about satellite communications from the space station, from Mars, from the moon, what are the constraints of those networks in terms of maybe its capacity, maybe it's you can only connect once or twice a day?
There's a few bottlenecks. One is of course the capacity of the link. We're used to satellite communication in low Earth orbit or LEO orbits or maybe geostationary orbits around Earth. But here we're talking about a single link that goes from the moon all the way back to Earth for 250,000 kilometers. So that's a long range. And the particular satellite that's being used for this mission doesn't have that much capacity. I think in the future we can expect to see higher capacities, and there's a lot of technology being developed to improve the throughput on these direct-to-Earth links. But right now that's still fairly limited, even though it's a major step compared to what we're used to seeing or what we've seen in like Apollo missions, for example, when we were on the moon. Of course, the other part is the delay. It's not just the capacity of the link from moon to Earth. It's also the delay of sending information back, because ultimately we're limited by speed of light, and so that's then also the constraint of the delay. And so when you look at space communication, certainly when we get to the moon, but also when we get to Mars and deep space, technologies like delay tolerant networking become very important to address the latency issues and the delay in the communication, because you don't want your communication to time out just based on the natural latency on your link.
How far is it, or how much latency are we talking about? Is this an hour? Is this a few minutes?
No, we're talking about a second and a half to 2 seconds.
Oh,
but I think we're also accustomed to everything being instantaneous, that even a couple second transmission delay, then you may have video compression, decompression, encoding, decoding delay, and so forth. But really just the time to transmit the signal from moon to Earth, we're talking about a 1.5 to 2 second latency. And I guess it's just a reflection of we're used to everything being instantaneous in our communication these days.
It is true. We are an impatient people. These are all big things to overcome, but there are even more. So let's talk about some of the challenges associated with building a network on the moon, which I guess the first challenges are probably getting the equipment up there, because it's a pretty rough process to launch a rocket.
Yeah, absolutely. As much as I said, we want to demonstrate that the technologies that we've developed for terrestrial communication, we can reuse them. Of course, we need to adapt them for space communication and the environment. And a lot of the research and a lot of the development that we're doing for this project is really around the environmental conditions. And it starts with rocket launch. You have to be able to survive shock, vibration, acceleration on the rocket. You have to be able to survive the transit to the moon. You have to be able to survive landing. And then you have to be able to operate the equipment in a very harsh environment as far as the temperatures are concerned, as far as radiation is concerned, and so forth. So there's a lot of real environmental challenges that are very extreme compared to what we would encounter on terrestrial deployments. And of course, the other aspect, when you go into space, size, weight, and power matter tremendously. So we have done a lot of work to really integrate all the network functionalities that we would need to constitute really all the components of a cellular network, integrate that in something that's, say, a small pizza box size equipment. So a lot of hardware integration, a lot of software integration, as well as then a lot of the environmental hardening that's required. And that's both from a hardware perspective as well as software perspective. This is an uncrewed mission. As much as I would love to go on the mission and be the technician to reboot the equipment if it has to be, this is an uncrewed mission. So our network has to operate completely autonomously, has to self-configure, self-optimize itself. So a lot of effort has gone into the robustness, the reliability of the network itself, as well as the operation of the network.
Let's talk about some of that. So I guess we can tackle it by challenges. Let's talk about dealing with radiation and temperature changes, because the moon it gets real hot and it gets real cold. And then with radiation, I don't even know how that would affect. We'll talk maybe about your physical stuff, and then we'll talk about radio stuff.
Yeah, so if we talk first about the temperatures, we will be operating during the lunar day. So it's a relatively short mission, between 12 and 14 days, Earth days, but it corresponds to a lunar day. So when we have to address the hot temperatures on the moon, but we're not planning to operate during lunar night when it gets really cold. So that's one constraint on the mission, and that's as far as our equipment is concerned, but also the partner equipment is not built to survive lunar night from a temperature perspective. And of course, that's something that if we project this forward for using this equipment in other missions that have longer duration on the lunar surface, that's something that will need to be addressed as well. On the radiation side, Stacy, one of the things that we discovered that radiation tends to cause bit flips. And so what can we do from a hardware as well as software perspective to guard against bit flips? Because if you have bit flips in your software may not run anymore, may not run reliably, may not run accurately.
Is a bit flip just my 0 going from 0 to 1?
Yes, and that's the effect of radiation on electronics equipment. So now, of course, you can imagine if you have too many of the bit flips, then your software is not executing properly. So not every hardware component is equally susceptible to the radiation effect. For example, if you look at different types of memory, not every type of memory is equally susceptible to the radiation. So we looked at in what kind of memory we should store our software to be more robust. And then we look at software features to recover from it. We have multiple copies of our software, for example. We have automatic reboot of the software for detect any issues. So there's lots of things that you have to do to really either prevent the radiation effects from happening. And you cannot prevent radiation, but you can look at mitigating the effects of radiation on your software from a hardware perspective or from a software perspective. And then when you do have the exposure, then how do you recover from it? And a lot of that is detection and then rebooting the software. And so we've done quite a bit of work in terms of rebooting the system automatically, but also storing multiple copies of the software so that we could re-image the equipment if in a worst case scenario. It's quite fascinating, and it's one of the problems that we did not, unless you really get into the space, we did not really look at this, and it's not something that you would typically look at when you deploy a network on Earth, but it's one of the fascinating technical challenges that we had to address.
I like that the solution, even for something as complicated as building a network on the moon, it's still, it's not working. Reboot. Go computing. Let's talk about like RF issues in space. I don't know, like the lack of oxygen. I don't know about like what spectrum is available to use. I'm just thinking about all the things about how things work on Earth and what of that translates to RF in space.
Yeah, let's maybe start first with the RF propagation. The lack of atmosphere is not a concern. We can definitely send electromagnetic waves and send wireless signals on the lunar surface. Of course, the curvature of the moon is different from curvature on Earth, so your horizon is much closer. But on the other side, you don't have buildings, you don't have trees, you don't have a lot of obstruction, so you're pretty much in a line of sight environment, except if your rover or your hopper would go into a crater. On the other side, we're used to deploying our antenna on the side of buildings or towers along the highways. So our antennas are mounted much higher, and in our case, the antennas will be mounted on top of the lunar lander, which just for reference is about 4 meters tall off the surface. So that affects our propagation environment and affects the coverage range that we can get, because the antenna are mounted much lower to the ground than we would see in a normal terrestrial network deployment. But we've taken all of those things into account. We created simulation models. We created some tools to evaluate the range that we expect and the throughput we can expect as a function of the range we have. But there's lots of assumptions that go into it: the antenna height, the antenna gains, the antenna patterns, transmit power, spectrum, and so forth. So we developed this pretty comprehensive tool, and it's really an extension of the tools we use for terrestrial networks. But one of the objectives of the mission is also to take real measurements on the lunar surface and then be able to calibrate our simulation tool and our models against the actual measurements, because these will be the first measurements that are actually taken of this system on lunar surface. And while we have a lot of experience with deploying networks on Earth and measuring propagation environment, this will be the first time we measure the actual performance on the lunar surface, and we can then use that to tweak or calibrate our models, and that would be very useful for future missions as we deploy more of the cellular technologies in the future. We'll have more confidence in the models when we predict coverage, when we predict throughput, when we design the network deployment to support future missions. So that's another quite exciting area just to to extend what we're used to doing on terrestrial networks. And it's the same, but not quite. It's similar, but not exactly the same.
And when is this mission taking place? And then how long will it take to kind of gather this information and research?
So the mission is targeted for the end of 2023, and the mission itself, it will launch out of Florida. The transit time to the moon is relatively short, a few days. The mission itself will be about 2 weeks on the lunar surface, and we get continuous data as our network operates on the moon. So we will get status information and performance telemetry data from the network as it's operating on the moon.
Awesome. All right. And you're doing a lot of work here. And I have to ask, aside from this being super cool, how will this help develop networks here on Earth? What are the takeaways here that are going to help?
I think when we look at a lot of enterprise and industrial applications on Earth, not just the consumer networks that we're used to every day, but more and more we're taking some of these advanced technologies into enterprise and industrial applications. And here I mean things like remote mines, offshore oil rigs, wind farms, factories, and so forth. And some of these environments are also fairly harsh environments, maybe not quite as harsh as the lunar surface, but they have some of the same characteristics in terms of temperature, dusty environments, shock, vibration might be concerns. So I think we'll learn a lot of lessons that we can bring back to how we deploy and build networks for these harsh industrial environments on Earth. Also, in a lot of these scenarios, size, weight, and power matter. So being able to integrate a lot of network functionalities into a very compact form factor is equally beneficial for those deployments as well. And then finally, the whole software optimization, automation of networks, self-deployment, self-configuring are aspects that are also very important for networks in the future. We want networks to be more autonomous, more self-aware, self-configuring, and we're doing that on the moon by necessity, but it's an important criteria for networks in these remote areas as well. If you think about a remote mine or an oil rig 20, 30 miles offshore, you want those networks to also be reliable, robust, self-diagnosing, self-optimizing, self-configuring. And that's also an important advance that we'll do on the moon.
Excellent. All right. Well, Thierry, thank you so much for coming on the show this week. I really appreciate it.
Thank you, Stacy. It's my pleasure, and thanks for having me.
Okay, so thanks everyone for listening to this week's Internet of Things podcast. I really appreciate it, as does Kevin. And if you want to find out more information on the Internet of Things, you can find it at my free weekly newsletter that comes out every Friday. You can sign up for that at www.stacyoniot.com/newsletter. Or you can just visit the website for all of those stories published a little bit later. Thanks for listening and have a great week.